Hey guys, so here back with another video. Today we're going to talk about the most important thing, the key to your entire year, the hub on the wheel. If chemistry was the Avengers, this would be Tony Stark. So this most important topic in all of chemistry is factor labeling. Factor labeling is how you combine numbers with different units to get an answer. You're going to have so many factor labeling problems this year, just over and over and over again. You're going to have to combine them with harder and harder topics. So getting this down at the beginning of the year is the best thing you can possibly do. So let's go ahead and do one very simple factor labeling. Well, the simplest way to think about it is it's any problem where you start with one unit and end with another unit. So if I were to ask you, how many days are there in a year? That's technically a factor labeling problem because you're starting with years, 1 year, and we're going to turn that into a number of days. Now, hopefully, this isn't a very difficult factor labeling problem. I'll bet you actually know the answer right off the top of your head because the number of days in 1 year is 365.2422. And I know you know this because, of course, everybody knows that the Julian calendar of 46 BC was eventually superseded by the Gregorian calendar promulgated by Pope Gregory XIII in the year 1582, which, of course, had a day length of 365.2425 days, which is fairly close to the actual value of 365.2422. Again, this is simple stuff. Everybody knows that. So just for the purposes of this problem, we're going to go ahead and use the number 365 days because it is a little bit easier. But just so we all know, that's completely incorrect, and Pope Gregory is really mad right now. So the way we solve this type of problem, and I know this particular version is easy, but stick with me because we're going to do a hard version in a minute. So the way we solve it is by using conversion factors. And a conversion factor is a fraction that equals 1. 365 days divided by 1 year equals 1, because those two things are equal, right? 365 days is 1 year. And the great thing about this is that since that equals 1, we can multiply and divide by it, and it doesn't change anything, okay? You can multiply by 1, you can divide by 1, nothing's going to change. So 1 year times 365 days over 1 year times our conversion factor is going to equal 365 days. And you can see when we cancel the units that the units cancel out right. This is really important. Canceling out the units in your conversion factor is the easy way to do it, because if the units come out right, then you probably did the problem right. Now let's imagine for a minute that we did this the wrong way. Let's imagine that we said, okay, 1 year divided by 365 days equals 0.003 days. 1 year is 0.003 days. And I know you're probably laughing at that, like, why would I ever do that? Oh, you're going to do that. You will make this mistake this year. You'll do it probably on a harder problem, but I guarantee there will be some point where you divide something you should have multiplied by. So let's say we make that mistake. Let's say we accidentally divide instead of multiplying. It's going to be really easy to tell that that's what we did when we look at the units. Because look at this. Now we have years on top. The years do not cancel out. Suddenly it's like years times years over days. It's a mess. So if the units don't cancel, then you did something wrong. So let's go ahead and try something a little bit harder. How many hours are there in 1 year? Now, this is definitely a factor labeling problem because we're starting with years. We need to get to hours, but you're going to require 2 conversion factors to solve it. You're going to need years to days, and you're also going to need days to hours. So here are the 2 fractions we're going to multiply by. Set up. We got years, days, hours, and then we're going to cancel, and you're going to see 365 times 24 equals 8,760 hours. There are 8,760 hours in a year. Now, remember, if the units cancel properly, you probably did it right. As a general rule, if the units cancel, you're fine. Of course, if I were to ask you a harder version of this problem, like, say, how many minutes are there in a year, obviously you're going to be in big trouble, because then you're going to have to use not 2, but 3 conversion factors and set up 3 different fractions to get there, which is basically impossible, right? Now let's imagine I really went off the deep end and asked you how many seconds there were in 1 year. Well, clearly, there's something wrong with me, because the only way to solve a problem like that is to use 4 conversion factors. 4. The number after 3, 4. You're going to have to cancel 4 different units, 1 by 1 by 1 by 1. And I'm just going to tell you, that's a hard problem. Any problem that requires you to cancel 4 units is probably harder than anything you're going to get this entire year in chemistry. Unless you're doing a really high-level honors class or AP, you probably won't have to cancel 4 units. So if you can figure out how many seconds there are in a year, you're already doing problems harder than anything you're going to do in an entire year of chemistry. So because this problem is just so insane, I'm not even going to tell you the answer. You're going to have to go over to the classroom page, and there'll be a homework assignment that you can do. And by the way, you really, really, really want to do some homework on this. Practice makes perfect when it comes to factor labeling. So here are the 3 other problems I'd like you to do for homework. And again, the answers to all these are going to be over on the classroom page. Number 2, how far is it from New York to LA in inches? And here are your conversion factors. Number 3, how much would a 1-gallon jug of solid gold weigh? Like if you had a milk carton full of gold, how much would that weigh? Here are your conversion factors. And the final problem, and I'm proud of this one, how many baby aspirin would it take to kill a blue whale? Please do not try this at home. I don't want you to do this experiment. We're just going to try and guess how many baby aspirin you'd have to give to a blue whale to kill it. Okay, and here are your conversion factors. So that's it for today. Thank you so much for your attention. Again, go try this. Go to the classroom page and give this a shot, and I'll see you on the next one.